One internet technology we look at during the iLabX is the domain name system, or short DNS. You might have heard that name already, as DNS is a core part of the internet we know today. Now, what is a domain name system? Imagine you want to access your favorite site, being it Google, TUM, or edX. As you should know, the servers that host the site you want to open are actually reachable via their IP address using IPv4 or IPv6. But you don't type an IP address in your browser's address bar, right? You might be able to remember one or two, but at least when it comes to IPv6, IP addresses become pretty unhandy. For DNS. The job of the domain name system is to translate between domain names and the according IP addresses. So instead of typing IP addresses, we use domain names like tum.de, google.com, or edx.org. These are way easier to remember, and we don't have to bother with the actual address of the server behind it. In our case in the lab, we will have a more specific look at the honey.b-shop.ilabx domain, which we use to set up our own domain names and DNS system. As a quick summary, DNS is a worldwide decentralized database for naming hosts. Its most important parts are domain names, name servers, and resolvers. During the course, we cover all of these components in more detail. Now, let's have a quick outlook. The domain name system in general and domain names specifically follow a hierarchical structure. Regarding the domain names, each single element in that structure is called a label. At the top, we have a dot as root element. On lower levels, we could, for example, have the labels org, Wikipedia, en, or de. And if we follow that example, we could also have these labels. And when we combine all labels from the bottom to the top, this gives us a fully qualified domain name. So in this case, for example, www.google.com. Note the dot at the end. Usually we skip this in practice, but it is part of the domain name. And therefore, if you really want to have the full domain name, you have to use it. Another example we use through the course is our own imaginary honey.b-shop.ilabx domain name, which we can see here. Finally, looking at the different layers of these structures, the zone at the top with the dot label is also called root zone or root domain. The layer with the org, com, iLabX labels is called top level domain. And afterwards we have the second level domain and so on. As there are so many domain names, name servers cannot handle all of them alone. So they have to split the work. Therefore, they are also organized hierarchically, and each name server is responsible for a certain part of the domain namespace. For example, the name servers in the root zone can tell us where to find name servers for certain top-level domains as de or org or iLabX. These in turn can tell us about second-level domain name servers and so on. It is the job of a resolver to go through this hierarchy until he can answer a request of a client. Let's look at this example. The client, or his browser, wants to know the IP address for honey.b-shop.ilabx. Therefore, he sends a DNS request to his resolver, asking for the IP address of that domain. The resolver starts by asking the root server about the IP address, as every resolver or name server knows how to contact the root servers. The root servers themselves are not responsible for that domain we are interested in, but they can tell the resolver about the top-level domain name server that is responsible for the iLabX top-level domain, which is the ns.ilabx. This one is then queried next and can tell the resolver that he should ask the name server for b-shop.ilabx. Finally, this one can resolve the domain name to an IP address, which the resolver then returns to the client. Now the client can use that IP address to open the site he wanted to open, honey.b-shop.ilabx. Yay! Last but not least, let's have a short look at how name servers actually know which IP address maps to a domain name or which name server is responsible for a certain subdomain. Each name server has a list of DNS mappings stored in a so-called zone file. Each zone file contains so-called resource records that describe DNS entries. Let's have a look at this table as an example. The first resource record is of type NS, short for name server, and tells us that the name server ns.b-shop.ilabx, see the data field, is responsible for the domain b-shop.ilabx, see the name field. The second line is of type AAAA or quad A, which means it contains a mapping between a domain name, in this case the name server from the first line, see the name field ns.b-shop.ilabx, to an IPv6 address, see the data field. The last two lines contain other examples for A or quad A records, where A records are used for IPv4 address mappings. Next, we have a short look at a practical exercise for DNS in the iLabX course. Let's have a look at the practical DNS and web server exercise that you can expect in the iLabX course. As with other exercises, we start in our virtual environment and use the core network emulator in order to emulate our test network, which we can see here. As you can see, we have multiple components that play a role in the DNS lab. First of all, we have a web server. The web server just serves two websites, which can be accessed by the clients. During the lab, you will set up the websites yourself and learn how to make the web server actually serve these websites to other hosts. For now, they are just readily configured. Next, we have some clients on the left. These clients in the lab just want to access the web server. However, they want to do that using the domain name of the web server and not the IP address. Therefore, we also have set up a DNS system and can see that we have a root DNS server, a top-level domain name server for the iLabX top-level domain, which we invented for that course, and a second-level domain name server, which is responsible for the b-shop.ilabx second level domain name and can map the domain names of the websites here to the IP address of the web server. Good. Let's have a look at the practical part. So first of all, we can start Firefox on one of the hosts. So the Firefox that just opened behaves just as if I would have opened it on host 1 here. So now I can try to access one of the websites. Let's say honey.b-shop.ilabx. And if I try that, it didn't work. The reason for that here is simple. We have DNS already completely configured. During the hands-on part, you will do that yourself. But for now, there's only one thing missing. On host 1, we have to tell him what host he can use as a resolver. We can do that in that /etc/resolve.conf file. If we edit that, we can just remove the comment here, and now this basically tells the host that as name server or resolver, he can use 2001:db8 and so on, which is the router here, which is configured as resolver. If we just save the change, and then you can close that window, and try that again. It works. Perfect. Now we can also try to open the second website, which is candles.b-shop.ilabx, which also works. Last but not least, during the lab you will not only look at the final result, like yay, you can open the website in the browser, but you will also look at what does the resolver actually do. And for that purpose, we will use Wireshark, which is a tool that just captures packets or messages sent over the network. And here we can see, so don't worry if you don't understand it, we can see that in the first line, this basically tells us that the resolver with this IP address sent a request to the root DNS server, which has this IP address, asking him for the IP address, IPv6 address here, type quad A, for candles.b-shop.iLabX. The root server is not responsible for that domain. Therefore, he sent us that responsible name server, which is iLabX name server. And he also includes the IP address of that name server. So next, we ask this name server, again the same question, what is the IP address for candles.b-shop.iLabX? And he again tells us the responsible name server is b-shop.iLabX. Finally, we ask this name server, and this one then can answer us with the IP address for candles.b-shop.iLabX is 2001:db8:b and so on. This one is then returned to the client, and the browser of the client can then just open the connection to the web server using that IP address. If you enjoyed that small teaser, then have a look at our course once we go live.